So all these days we have used Citrix MCS technique, using the hypervisor cloning capabilities. We provision the mission catalogs. So using the MCS mission creation services, we created those mission catalogs. But there is one more traditional method is there, that is called as PVS. So PVS stands for Citrix Provisioning Services. So PVS is also is one method of creating the mission catalogs. Okay, so what is the main purpose of PVS, MCS? Both are like same use case, like both are imaging kind of things, but we have two different techniques. Okay, so both are two different techniques. PVS stands for provisioning services, like till Zen Desktop 4, there is no MCS concept. Citrix used PVS itself. From Zen Desktop 5 onwards, MCS has been included, but today mostly we are using MCS itself, but PVS also 20 to 30% of that desktops are provisioned through PVS. And in order to set up the PVS, we required a PVS servers are required. We required PVS servers are required. So from those PVS servers, we are going to deliver desktops. Yeah, any doubts on this? Any doubts?
Can you explain again what is PVS?
Yeah, Citrix PVS is the provisioning services. Using the PVS, we are going to deliver like a, uh desktops itself. Okay, so even this is one technique. Say in the Zen desktop, we have two types of imaging. One is MCS, second one is PVS. So PVS stands for provisioning services.
Services.
Yeah, provisioning services. We need to install a PVS server also on one mission. From that, we are going to boot the devices. Okay, so from that we are going to boot these devices. Today we'll discuss how PVS works. All those we'll discuss. The main purpose of PVS is like we no need to maintain, even with the MCS also we no need to maintain, but large number of computers by operating system installations, all that we no need to do. Whereas MCS uses linked clone kind of techniques. MCS uses the linked clone kind of techniques, whereas PVS uses streaming capabilities. Okay, so at the time of booting itself, the streaming is going to happen, and the devices uses one single V disk. The devices uses the single V disk, and from that multiple target devices are going to boot. So I'll tell one use case. So we don't have any like a hard disk. Today we got 1,000 physical missions. Once we got into the 1,000 devices, connect to the network, power on, automatically the desktops will boot. Okay. So what is that meaning is that locally we don't have the hard disk also. But from where it is booting,
PVS.
so where it is booting from the network, it is booting. Okay. And who is delivering that boot image? In the Citrix environment, PVS is delivering that boot image. Okay. So that means if we have even 100 desktops or 1,000 desktops and even server class also, all the 1,000 missions are booting from single image. That image is called as vdisk. That image is called as vdisk. So that's PVS using this streaming capabilities. In MCS, what we are doing is MCS we are cloning that. We created one golden template, and that mission has been converted into thousands of linked clones. But in the PVS, what we are doing?
Yes.
So in the PVS, We are
Yes, sir.
converting that image into single
Single image. Streaming to
single disk image. So from the V disk, okay. So from that V disk image, we are booting that into multiple devices. Okay. So in the V disk, whatever the operating system we have, applications we have, all those, even the 1,000 devices also can boot. Okay. So that's even if any installations, like if we have 1,000 missions, how many installations we have done? How many installations we have done? Only
One.
one installation. Updates, patching,
only one.
only one itself. Okay. Say even compared to MCS, there are some advantages with the PVS in the large scale environment. In the small scale, that means you have less than 2,000 kind of desktops. MCS is the best method, but in the large scale production environments, still PVS have some advantages. But disadvantages, like additional, we need to maintain even the PVS servers or PVS form also we need to manage. That's again little complex kind of thing. But in the large scale environments, this is suitable for this. And not only for the Zen desktop, even the physical virtual devices can boot they can boot from the single image, they can boot. Okay, so that is also one of the advantage of PVS. Not only for Zen desktop, assume we have even 1,000 physical desktops also. All those can be booted
Itself.
from the desktop. They can boot. So that is also one of the advantage of PVS. Okay, and here that it's going to stream over the network. Okay, so what is the meaning of centralized management is updates, rollbacks, all those can be done from single image, and the PVS streaming from the central location is going to stream. Okay, so then even we have the high availability load balancing features also we are going to manage. Okay, so we are going to manage those high availability. Even one PBS server goes down, we'll have the another PBS server. So those all the benefits also we are going to get with the PBS environment. All this we need to install the PVS, and even PVS is suitable for the large scale deployments. So what is the Citrix recommendation is you have less than 2,000 desktops, then better to go for MCS. But more than 2,000 desktops we have, storage wise, hypervisor wise, more benefits will come with the PVS itself. Okay. So but for small scale environment, instead of again maintaining the PVS, better to go for MCS itself. Means today when we are working as a Citrix administrator, so what we required is we require the capabilities of both we required. Both we need PVS we required and MCS also we required.
We can use same time.
Yes, yes, we can use same also. So some catalogs maybe with the MCS, some catalogs with PVS.
Previous and here.
Okay. So it's not only for the Citrix Zen desktop environment, even for the streaming capabilities also we can use. Okay. So we want 1,000 desktops or servers need to be booted from the single image. That image, what we are calling, is a V disk. V disk. Okay. So from that, it's going to deliver. Okay. So in the uh, mm, MCS, we are creating a golden template kind of thing.
Good template. Yes.
Okay. That master image. But here in this, that master image, we are calling as like a V disk we are using. Okay. And even if any changes is required, we are going to perform like a update of the vdisk we are performing. If any changes need to be performed, we are updating our vdisk itself need to update. Then all the 1000 missions also will upgrade to the higher patch version. If any changes need to be done, so those all the changes we are going to perform from the single image we are going to perform, and those we are going to update that. So how to update the vdisk is the mandatory activity if we are using PVS environment, because maybe for 2 weeks, 3 weeks, like if any updates comes, we need to update our vdisk itself. Then thousands of missions would be updated from the single vdisk itself. Okay, so then first we need to create the vdisk. Then the target devices are going to boot from that vdisk. Then when the device boots, like from the vdisk is going to stream over the network. Over the network is going to connect. Okay, so then all the user data is going to be in the MCS. What's happening is, once we create a catalog, the mission's user data is going to be, that means whatever the user data is stores in the differential disk, means a additional disk is getting created in the differential disk is going to store. But all the desktops will use the single image itself. When we create a catalog, when a clone is going to be created, say we have 32 GB clone is getting created, then the data is going to be stored in the differential disk. Okay, now in the 1000 desktops with the PBS, all the 1000 devices will boot from vdisk, and the user, whatever the data is going to be stored, that's going to be stored in write cache. So in the PBS, it's called as write cache, and in the MCS where that is storing, that data is going to stored in a differential disk. In a differential disk, the data is getting stored. Okay, say nowadays after virtualization, like a like a simplified management, is become with the virtualization. But even in the physical environments also, when we have the thousands of devices, like a very simple single instance management is possible with the PVS. And rapid deployment, consistency, flexibility, all these we are getting by using the PVS. Okay, so hence PVS. Okay, say I hope you know about PXE. So PXE is the booting process. From that pre-boot execution, the devices are going to boot. Okay, so here PVS is not using any advanced technologies. Okay, so very basic technologies itself is using, but Citrix made it the solution is very innovative kind of technologies. Like in the when the Citrix PVS has been released, like a lot of companies are assuming it's a alien kind of technology, because without doing anything, just to power on your devices, thousands of devices, like those devices are getting the operating system. And strangely, we don't have the hard disk also in those devices. Okay, so without having the hard disk, from where those devices are booting, it's a network booting itself. Now, normally now even in Windows also we have that network booting, right? So today Windows also is giving the network booting. Okay, so but Citrix has given very initially and integrated with the desktop virtualization kind of solutions also. So that's the reason people has used this technology very rapidly. They have used, and even Citrix engineers also having good expertise on the PBS will give more success for them. Only today, as of now, 70% or 80% MCS itself is using. Lot of engineers doesn't know, even working guys also doesn't know PBS. But better to have the PBS knowledge when we want to go for an interview. Okay, so then what are the ports used by PVS? We'll discuss. Say here PVS in the PXE boot process, it using TFTP kind of protocol, and using the TFTP protocol, it's going to get the desktops. So using the TFTP protocol, the devices are booting. Okay, so now here those devices are booting. So why the TFTP will comes into the picture, we'll discuss. Okay, for that it is using 69 is the port number. And definitely in the devices BIOS, we require to boot from network option. Normally we have boot from floppy, boot from DVD, boot from hard disk, boot from networking, like that. Definitely the device need to support. The device need to support boot from network option, need to be supported. Then when we supported boot from network, it's going to be using PXE kind of environment. Okay, so for that it is using 4011. Okay, so over the network, if you enable PXE kind of thing, pre-boot execution, okay, so that's going to use the 4011 kind of port number it is using. And on the DHCP level, we need to configure 67 and 68 we are using. 67 and 68 we are going to use for the DHCP for the booting server. That means what is the uh, like boot server in our environment is PVS is our boot server, but like the devices when they are booting, they can't identify what is the boot server. Who is redirecting to boot server is DHCP is DHCP is uh, redirecting. Then how DHCP knows is in the DHCP server we need to configure boot settings with the 67 and 68. Then whenever the device boots, it goes to DHCP using the DORA process. Then after DORA is done, like DHCP now is doing DHCP is doing redirecting the request to boot server also. That boot server settings, like which is your boot server, in which port we are configuring, in the
67.
DHCP 67 scope option we are specifying, and 68 is for boot file. Okay, so 67 we are using for
Define
boot
that
server, and 68 is for
file.
boot file. Okay, so what is that boot server and boot file also we'll discuss. And whenever the device is booting, it need to get that vdisk. For that purpose, it's going to use streaming port numbers. Say here we have around 20 port numbers are there, 68902 to 6909. Okay, using these 20 port numbers, like the devices are going to boot. And we have SOAP server also is there between PVS server and PVS console. With the Active Directory, the communication is going to happen, and PVS SOAP server port number is 54321 and 443v9 3389. So these all the firewall ports also we need to open. Firewall ports also we need to open. Mostly with the Citrix release, they're releasing a PVS also. Citrix we are releasing the PVS also. Okay, so now here, like one of the prerequisite what we need to set up is, say in the DHCP server we need to set up like our 66 and 67 port number. 66 is used for
Server boot.
boot server, and in our environment that boot server is a PVS server where we have installed that server we need to install. And 67 port number is for
Boot file. Yeah.
a boot file. So in our environment. Yeah, DBP 32 dot bin. So this is your boot file. Okay, so the we need to provide the boot server is the IP address where we have installed, that is boot server. And what is the boot file? What is the boot file?
ARD.
Yeah, dpp32.bin is the boot file name. Okay, so these two we need to specify. Using that boot file is going to be delivered to the device. From that, over the network, it's going to boot. And using the TFTP, it's going to deliver. So the TFTP port number is 69. 69 is that. And in the Citrix, anyhow, we have the license server and we have PVS server database. So just like Citrix also we required one database, PVS database we have, and PVS console. Just like Studio we have, right? So here we have the PVS console. Okay. So then we have PVS servers. Then we have the PVS store. So store is nothing but storage kind of thing. Maybe in the real time it's maybe SAN also. Okay, so store where all that VDISC are going to be stored. Okay, from that store, like devices are going to be existing. Okay, and the form is like a global kind of thing, a region, and location wise we have the site and PVS servers. The main component is PVS server. Coming to like these components. Okay, so now here we have the what are the components in the PVS environment we'll discuss. So here we have the Citrix PVS servers or provisioning servers, and a group of them, all these we are calling as PVS form. And maybe location wise we can split them into zones. Location them into zones we have. And PVS console, we are using the PVS console to administrate using the PVS servers. Okay, then even we require PVS database also, and we don't have local host cache kind of technology for the database. So that is the reason we need to maintain PVS database we need to manage. So here we don't have the local host cache kind of thing. So we have, like, we need to manage the PBS database we need to manage. And for the high availability, mirroring or clustering we need to take care. So for the high availability, either mirroring is, that means we'll replicate that data to another PBS server, or at the SQL server level, we are going to specify the cluster settings. Okay, so these two, for the high availability of the database, we need to set up. Okay, then like we need to PBS store. So in the PBS store, like we are going to keep all the VDisk and all the devices we are going to get it from the PBS store we have. Then even PBS is also is not a open source. We require the license server to manage those PBS servers also. So we required like a license server is required. Then we required PBS agent also. So on the which mission we want to install, we want to convert into that. On that we need to install PBS agent. Then that need to be converted into like VDisk. We are converting, say, into VDisk we are getting. Okay. So here the we need to have the PBS VDisk we need to install. Okay, any doubts in this?
I got a question, sir.
Yeah,
Since everything's over streaming over the network, what's the network requirement? Like
network
what the
required good
speed?
bandwidth, but today network bandwidth is not a constraint to the companies. It's not over the internet.
Okay.
Okay, so that is the reason we need to replicate the PVS stores also from the nearest location will boot. Even we have a globally also. In the site we are maintaining, like from the nearest location we'll boot it. Okay, so here this is PVS target device. In one mission, we need to install PVS target device, all this. Then this need to be converted into VDisk, and technically that VDisk is stored in PVS store. But if you have multiple zones, replicate it into another zones also. Okay, so replicate that into another zones also. And we require network, we required a good infrastructure is required. License server also is there. And if you are not using like a pre-boot execution, mostly we are using pre-boot execution from the boot from BIOS. If you don't have that, then Citrix has given one more solution called as BDM, Boot Device Manager. So when we are using Boot Device Manager is, if you are not using, if you are not using PXE booting, if you are not using PXE booting, but we require good network infrastructure also is required. Okay, and that boot file, what is the boot file name? ARDB. What is the boot file name? ARDBP 32.bin. This is going to be delivered from the TFTP protocol. So TFTP is using which port number? License, sorry, we'll use 69 is the port number it is using. Okay, so now on the target device, like one reference mission we are taking, okay, on that we need to install PVS agent or target device agent need to be installed. Okay, then that need to be converted into VDisk. That need to be converted into VDisk. And where we are keeping that VDisk? Where we are
So
keeping that VDisk? In the PVS store, we are keeping that VDisk. And if you have the multiple like zones, then replicate across the, because for the, say suppose assume Hyderabad is one zone, US one, maybe one zone we have, then better to keep both in the different stores, better to keep. Because if the users are booting from the Hyderabad means like they will get the latency kind of thing. Okay, our company environment may be a farm kind of thing. That group of servers, globally, those are calling as PVS farm. But location-wise, we are splitting them into zones. We are splitting into the zones. We are splitting them. Okay. Any doubts on these components?
what about this VDisk? Oh,
Yeah. Once we install the
we-
agent, we'll convert that into VDisk. So there is one converter tool is there that's going to be written into VDisk files. It's going to write.
like image. Yeah.
Yeah, it's a file level we are getting. We can call that as a vdisk. All the hard disk files we are normally in the VMware we have VMDX files like this we are getting. So here we'll get the VHDX files.
So every machine, all machine, boot with VDisk, separate VDisk, or created itself,
No, no. All will use the same vdisk, right?
same VDisk.
All will use from the same vdisk. Those are getting booted. Okay.
For the data only, they're using uh, differential disk. You said
Yes, yes. Once the 1,000 devices uses, 1,000 also will use the same vdisk, but it will create 1,000 separate differential disk. That size is less.
size will be yes, yes.
Okay.
Okay.
So then, first we'll discuss one mandatory question people will ask us is, say we have a device, say almost 1,000 devices we got into the new devices, either physical or virtual. Okay, so those devices we connected to the network, we just to power on. We didn't install any operating system, and even though those doesn't have any hard disk also. Okay, so then like first the target device boots and acquires an IP address. Say it's going to get it from, in our environment we are using as of now DHCP. Then first it connects to the DHCP server, and DHCP server will assign the IP address. Okay, so then DHCP server, what are the configurations we need to do in the DHCP server? In the DHCP server, what are the settings we need to configure?
Server boot
So we need to configure 66 and
ports.
67 we need to configure. So we need to configure 66 and 67. With that, it's going to be redirecting to the boot server. Okay, that means device first will contact the DHCP over the PXE. Okay, so then like a DHCP server will redirect to boot server, and boot server will deliver boot file using the TFTP. Okay, say in our environment, our TFTP server also is our PVS server itself. Means at the time of booting, like PVS server is acting as a TFTP server, and what is the responsibility of that is? What is the responsibility of that? It need to deliver the
Disk.
it need to deliver that boot file. So what is that boot file name? Yeah, dbp32.bin. Okay, and using which port? So 69 port number it is going to boot. Okay. So then that bootstrap file would be downloaded and the target device will boot from that. Okay. Then again the target server will contact login to the PVS servers. Okay. So then like proceed to the login, the device contact the PVS server, and like a port number it is using is 6910. Then PVS server like a response with the IP address and port number to continue. Okay. Then like target device will get that MAC address. Every device will have the MAC address, and based on the MAC address we are allocating which VDisk it need to boot. Then PVS server is going to search in the database for this device what is the MAC ID has been allocated. Based on that we have VDisk is going to be allocated. Okay, then like PVS server replies with all the disk and all those, and it will get that which VDisk it need to connect. Then it's going to give the grant the permission. Okay, that VDisk is going to be streamed using the 69102, that port numbers using that is going to communicate. Okay, then all the VDisk information, if you have the larger VDisk, the complete information is not going to be stored. What it required to boot, that's going to be stored. Okay, and it sends all the VDisk information also, including the write cache location, all that it is going to store. Okay, so that's we'll discuss how that is going to boot also. We'll discuss. Okay, so that's so this is another way of explaining. Like here in the previous boot process, that either this may be a physical mission or virtual mission is getting power on. Then like uh, definitely we need to enable boot from network. Even we don't have hard disk, CD, any boot devices we don't have. It's maybe fallback to boot from network itself. Then like here is going to be we are connecting to the DHCP server, and DHCP server we need to configure 66 and 67 we need to specify. From that, in the DHCP scope option 66, we are specifying the TFTP boot server, and in our environment PVS server itself is our boot server, and the boot file rdbp32.bin. So using this 66 and 67, that's target device contacts that TFTP server. Okay, then TFTP server will read that boot file, and that information is going to be delivered to that using the 69. Then, after that, in that boot server, we have the list of PVS servers. It's going to communicate with the PVS server streaming service, and that PVS server will identify the MAC address, and based on that, it's going to communicate with which MAC address it need to communicate. Then, here we need to get that what are that VDisk has been allocated to that device. Using that device is going to be booted. Okay, so then here are the high level, first the device boots and acquire the IP address, then target device identifies the TFTP server, then bootstrap file is getting downloaded, then from that bootstrap file it will contact the PVS server, then among the PVS servers a load balancing also will happen. The least loaded PVS server, least loaded PVS port is going to stream that VDisk. Okay, so then target device will stream from that VDisk, store from that PVS server. Like this, the devices are getting booted. Like this, the devices are getting booted from that. Okay,
Least port, what did you say? Come again, please.
come again.
Least port, what?
Which?
Least port, what did you
Yeah,
say?
yeah. Say here, what are the port numbers it is using for the PVS streaming is? Okay, so for the PVS streaming. So here how many port numbers are there? 68902.
It's
This is
nine.
almost 20 ports. So assume we have four PVS servers. I specified one logon server, one server details I specified. Then among those servers, one PVS server is having 80 sessions, another one having 60 sessions, another one is having 50 sessions, another one is having 100 sessions. Then which one is least loaded among them? That 50 is the least loaded. That PVS server is allocated to the user. Then again in that we have the port numbers we are using is 6890 to
6909.
69. So these all around 20 port numbers. Each port number will allocate 8 devices it can boot. That means 20 into 20 into 8 means total from one PVS server 160 devices can boot. But even that 8 also we can increase that number. But as of now this is then assume 6890 port is using 5 sessions are connected. Then 6891 is having only one session. Then it may try to allocate 6892 because that is the least loaded port number. Okay, so first logon server will identify the least loaded PVS server, and in that we have the port numbers like 6890 to 6909. Okay, so that's we have almost 20 ports. Then which is the least loaded port number? From that port number we are going to identify to deliver the desktops. Yeah, any doubts on this? Any doubts on this?
This, this VDIS will be provided, allocated from this port, any port within
Yes,
this
from that
20.
least loaded port which is identified, from that it's going to be delivered. Okay.
How it will allocate any how it means allocate any it is itself, and allocate any, or is it any?
Yeah, yeah. So now here, like what is the process? I'll explain. We have the PXC, that means target device over the network is booting, DHCP, DHCP to TFTP server. One previous server itself we have chosen as TFTP server also. Then, like in that we have the previous server details are there. Okay, that previous server is a logon server that is going to identify which server need to be assigned to the user, that to the target device among those previous server. Then it is doing a load balancing by recognizing least loaded server and that port number. It is doing the load balancing. From that server, the device is going to boot. From that server, the device is getting booted. Yeah. Any doubts on this? Yeah. Any doubts on this? So here TFTP server, previous server, and which is streaming, that all are same, all are previous servers itself technically. But in the DHCP, what is the previous server we have allocated? That server is our TFTP server. Later in the TFTP server, we'll have the boot server details in the failover order. Then the first previous server is acting as the logon server. Then that logon server will identify among those servers which is least loaded, and least loaded port number is going to be allocated, and from that allocate attached store that vdisk is booting. Otherwise, if only one previous server is there, some hundreds or thousands of devices are booting, it can't accommodate. Okay.
How is the MAC address? You said
Yeah,
noun
MAC
or
address, like what we need to do is, say we have the 1,000 devices we have. Okay, say in the PVS server, what we need to do is that 1,000 server MAC address and which corresponding vdisk we need to attach. That's we need to specify. Then, like it's going, that PVS server is going to contact the database server and recognize what is the vdisk that need to be attached to the user.
is it MAC address will be manual attached,
Yeah, manually we need to attach.
or every time we are
No,
attaching?
no, only one time, right? So whatever the devices MAC ID, because authentication is going to happen based. So assume I have one Windows 10. I have one vdisk. Then Windows 11. I have one vdisk. Then Windows Server 2019 with the Citrix environment. The device it need to boot from which one we are going to allocate based on the MAC ID we are allocating. Okay. Otherwise, it doesn't know which MAC ID it need to be attached to that.
While configuring this, we have to
Yeah.
attach.
At the time of devices, once we got those 1,000 devices, we need to get those MAC IDs and we need to attach that. This is one-time activity.
Through MAC, they will identify.
Yes, yes. From the hardware vendor also, we'll get those MAC IDs. Okay. So once you attach that MAC ID, based on that, it's going to search the database, what is the MAC ID and vdisk has been allocated. From that, it's going to boot. So for the same MAC ID, if you allocate multiple vdisk, then what is going to happen? If you allocate multiple vdisk options, if I enable, then what is going to happen?
Complete
It is going to give the dual boot option.
goal boot.
Okay, either choose this vdisk or choose this vdisk option, it would be selected. Okay,
If it is in same MAC,
same manner. So which one user selects, that would be booted, or what is the order we have given, after some time, maybe 10 seconds, 30 seconds, from that it's going to be booted automatically.
multiple windows and multiple disks.
Yeah, but one vdisk user will select.
As per user requirement.
Yes, yes. We don't select most, but only one we are selecting. Okay. So then if any changes need to be performed, only we need to perform vdisk update need to be done, not the 1,000 missions.
PDF.
Only one time we need to make it.
BDM also option.
Yeah, yeah. Say if we don't have PXE booting, then we have that BDM is the solution. It's not an enterprise large scale solution because we need to convert that using the BDM, we need to convert into one ISO image. That ISO we need to boot it in the devices.
It will be in same network, boot from
But
network.
that ISO we need to keep in each and every device. From that, it's going to boot it. That's not a best practice in the large scale
Absolutely.
environment.
Yes, yes, yes. Absolutely.
Okay, so automatically PXE pre-boot execution will recognize the DHCP. From that, is download the boot file. That is the automated solution. Otherwise, another solution what we have is
PDF.
BDM is the another solution. But in the large scale, no one will use the BDM. But technically, Citrix has provided the solution where we can't use
PX, PXE.
PXE. We can't use.
For maybe BDM is used for security purpose also, I think.
No, no. Even PXE is very secure. DHCP, all these communications are very secure. Not in the outside network, right? Only within the office network, we are using all this. BDM, like again, you need to burn that ISO from that device. It need to attach to the DVD or maybe that's long process from the USB.
Yes, yes.
Okay, and there is one more solution also is there. Some hardware devices having a firmware also. But nowadays we are not getting. But some Dell devices, those used to give a firmware also, that's automatically will boot. But with the virtualization, PVS lose the market. When we have the physical devices, that single instance management is like a lot of advantages we have. And in the initial days, the hard disk cost also is expensive. That cost can be reduced by PVS. Say 1,000 devices doesn't require any hard disk.
Yeah, hard disk also.
Yeah,
What about this? For PXE, will consumption of network
that is
bandwidth and
automatically is happening, right? Manually we are not doing.
bandwidth will be so
A bandwidth is like over the network, it's not a big constraint.
will be in
Yeah,
local server.
locally itself that's there. Only
And
the
so
criteria is network constraint is the solution. You
yeah,
require to
and
maintain good networking.
it will be in LAN only.
Yeah, okay. Now anyhow, license server is 27,000. Already we discussed this port numbers. So now whenever we kept the VDisk, VDisk wise we are getting VHDX file. Then we have the PVP file, log file. All the hard disk details are stored in VHDX file. Okay,
Okay.
all hard disk related, say we have 30 GB, 30 GB, all that is going to stored in VHDX. Okay, then like we have the PVP file, then log file. PVP file is sidecar file. Okay, all the meta information is going to be stored. And whether that VDisk is in lock or not is going to be stored in log file. And whenever we do the update for the first time, we are getting 1.vhdx, 2 dot. If you perform at 10th time, 10 dot
PDX.
vhdx file would
PDX.
be generating. Like for each and every time upgrade, we are getting those. Okay,
Not remove this old.
come again.
It will not remove old disk.
We can clean up those.
Clean up.
For the storage is the constraint, older things we can remove.
Yes.
Okay.
Clean up and we should go and delete.
Yeah, manually better to delete.
Manually.
Okay.
Okay. For this, we have to set up
Yes,
different
yes. We
servers.
set up on one mission, install PVS.
Yeah.
Install one Windows server. One second, I'll tell the steps. AD mission keep like that. As of now, controller stop it. Have controller right. Okay. So keep your domain like that itself. AD mission you keep like that. Then install one Windows server install. Okay. That Windows server 2019, 2016 also is fine. Join to domain. That AD you try to join them. And all should be in the NAT itself. Okay. Then on top of that, we'll install PVS. Then take one Windows 10 or anything Windows 11. On top of that, what we'll do is PVS target device. And we'll use the DHCP is on the same server. On the same server itself, like AD, DNS and DHCP is on the same server we are installing. Then database also as of now on that Windows Server 2019 itself will have the console, license server, all those also will install.
I was thinking that when we are performing other backup server like DC, what we call
No, no, if you have
controller.
snapshot, no need to worry.
No, controller. For controller, I have kept
Controller
ready.
as of now, stop it.
No, backup controller.
Yes, yes, that's we'll do later.
I kept ready for
Yes,
that.
yes,
It will take time.
that's we can use it.
Yeah. Windows 10 also ready. We have.
Okay, yeah. So on that I'll get that previous ISO. Okay,
If you have share,
I'll share that previous ISO. I'll share it today.
I will keep ready.
Sure. Tomorrow, these servers, if you're ready, then we'll start it tomorrow.
It is already ready. But I will
Sure, sure. Tomorrow,
download
tomorrow. Yeah.
tomorrow.
Okay.
Okay.
I need to download that ISO, I think. Once I share it, tomorrow we'll install. Okay. So what are the files we are getting is, so vdisk name dot vhdx vdisk name dot pbp vdisk name dot lok file. So that is a log file. vhdx file is the exact hard disk file. PVP file is having all the information regarding that vdisk details. All the meta information is going to stored in that. That is called as sidecar file also. Okay, lock file. Whether if the vdisk is in the use, that vdisk is going to be locked. Whether that vdisk is locked or unlocked is going to store in lock file. Okay. Then when we upgrade, like with that 1.vhdx, like this, we would be getting those. So once we created this vdisk, all those will integrate again with the controller. So how will integrate with the controller is, like we need to create PVS catalogs need to be created. We need to create PVS catalogs need to be created. Okay.
For real time, it will be different. We will use domain and Zen server only.
Yeah, that
Other will
VM will keep on that on the Gen server VM will keep, as of now, keep it in the workstation itself. Okay, so that means PVS supports both physical it supports and VMs also it supports. Whereas MCS supports only virtual machines and now they are supporting even cloud also. Okay, so PVS is not supporting cloud. MCS is not supporting,
physical.
MCS is not supporting
Physical.
physical devices. Got it right? So this we'll do in the tomorrow session. I'll share one video also how to set up this. That also parallelly go through once. Okay.